Today I will be explaining you WDM PON, LRPON and DWDM PON. This is the block schematic of a wavelength division multiplexed passive optical network WDM PON. It consists of an OLT section, a single optical fiber transmission line which carries different wavelength signals, a remote node mux or demux, and then given to the ONUs. A potential WDM based PON implementation is shown in the figure above. The optical line termination, that's the OLT, comprises of both WDM source and receiving units which send and receive WDM signals. An optical band pass filter OBPF is used to separate the optical signals between the transmitting and receiving units in the OLT. The OLT is connected to the remote node by a single optical fiber that carries bidirectional signal transmission, enabling two wavelength bands, one for the downstream and other for the upstream. The RN section incorporates optical multiplexer demultiplexer unit which usually comprises of arrayed waveguide grating, that is AWGs, and these devices are used to route WDM signal from the RN remote node to the particular ONU and vice versa. Such WDM, that's a wavelength division multiplex passive optical networks, are also referred to as wavelength routed PON, that is WRPON. It is also possible to employ AWG to route a band of wavelength signals to a specific group of ONUs, that's optical network units. This can be accomplished using a multi-stage configuration for the RN incorporating several AWG devices where each remote node stage provides access to a specific number of optical network units ONU. An implementation of a multi-stage WDM, that's a dense wavelength division multiplexed PON, showing a two-stage arrayed waveguide grating for downstream access in a remote node is shown in the figure, which consists of a first stage, that is 2x8 AWG. The second stage consists of 1x4 AWGs which are connected to the optical network unit ONU. So the figure shows a multi-stage AWD implementation of the RN in a WDM based PON. There is two stages here. The two stages AWG configuration comprises a 2x8 device followed by 8 1x4 AWG in each stage. It incorporates a downstream grouping strategy for a total of 32 ONU where a single 1x4 AWG serves an individual group of 4 optical network units ONU. It should be noted that current PON can serve only a limited numbers of ONU. They also operate over typical access network maximum span of around 20 kilometers. Longer transmission distribution distances for a PON can be achieved when optical amplifiers are incorporated and such a access network was initially referred to as Super PON, Super Passive Optical Network. These networks are now, however, more often called as Long Range PON. So, Super PON is also known as Long Range PON, LRPONs. The concept behind the LRPONs, Long Range Passive Optical Network, is to provide for the expansion of the physical size of the access network to over 100 kilometers, which may in certain location remove the requirement for the metro area network man in the telecommunication network hierarchy. The next topic for today is a LRPON. So this is the structure of dense wavelength division multiplexed LRPON. That's a DWDM LRPON. It consists of 4 sections or 4 operational sections. One is a core exchange, other is a local exchange, other is a street cabinet connected to optical network units. The section at the core exchange or the central office comprises a transceiver incorporating DWDM channels using a combination of AWG and an EDFA, erbium doped fiber amplifier. The DWDM signal has 100 GHz channel spacing, splitting the C-band into 2 halves, in which each carries both downstream and upstream channels. The middle section, which is located in the local exchange, functions as a repeater employing EDFAs and AGW, that's a arrayed waveguide grating, and the centralized DWDM optical source for each optical network unit ONU. The straight cabinet section mainly houses 1 cross N splitters to interconnect the feeder and distribution network sections, each of which is 6 km long using 2 separate fiber links. Finally, the customer ONU section incorporates an EAM, that's the electro-absorption modulator, monolithically integrated with semiconductor optical amplifier SOA, providing sufficient overall gain and bandwidth to support large splitting ratio and upstream transmission rate of up to 10 gigabits per second. So this hybrid LRPON structure demonstrated will have a total reach of 100 kilometers with the potential for supporting 17 TDM PON, each operating at a different wavelength with up to 256 ONUs, giving an aggregate network ONU count of 4,352. Now we shall discuss about LRPON. LRPON, there is a long range or super PON configuration, potentially connecting the access network directly to the core network. It consists of, only the LRPON we shall discuss, that consists of a feeder section and a distribution section. Feeder section starts from LOT, that is optical line termination, up to the remote node, and from the remote node to the ONUs is the distribution section. In the PON configuration, the feeder section incorporates optical amplifiers, while the remote node houses optical splitter and an optical amplifier to increase the optical signal power to provide for a greater number of splits. The passive optical splitter configuration in the distribution section following an amplified splitter can have a splitting ratio of 1 cross 128, 1 cross 1024, 1 cross 2048, or even more depending upon the network optical power budget.